Welcome. For this screencast, I just wanted to show you how to solve number 3 in a completely different way. All right, let's get started. You'll remember the problem. We have two ropes holding up a 50 kilogram mass. So our force diagram has weight going down, and at a 20-degree angle, we called that T2. And then at a 40-degree angle, we've got T1 pulling to the left. So this is my 40-degree angle, and this is my 20-degree angle. Okay? So we'll start the same way. Since the acceleration is 0, then all the forces should add to 0. But now we're going to actually add up the forces in the x and y direction. So now we're going to say since acceleration in the x direction equals 0, I took out the arrows because now I'm talking about along this x-axis. That's what I mean by x direction. And I'm going to do the same thing for the y direction. Okay? And I'll define up as positive, I'll define to the right as positive. So acceleration in the x direction is 0. Then we can add the forces in the x direction only, and we should get 0. Now we can do the same thing for the y direction. So since acceleration in the y direction is 0, then sum of the forces in the y direction equals 0. So this will allow us to use positive and negative to account for direction. The problem is, bummer, none of our forces here except for weight actually lie in the x or y direction. So we'll need to break up these forces into component forces. So let's go ahead and do that. I'll take my T1 going outward and to the left, and I'll break that into components. So this was my T1, and my T1 breaks up into T1 along the x-axis and T1 along the y-axis. And you'll notice that T1x and T1y add up to T1 the way vectors add up. So that's going to allow us to replace T1 with T1y and T1x. Okay? So, whoops. All right, so T1, y direction. Here, let me do this. I'm skipping steps. Let me go slower. Sine 40 degrees is going to be T1y over T1. Therefore, T1 is going to be T1y sine 40 degrees. And hopefully you realize that, oh, I messed up. Sorry. Let's scratch that and go back. Try that again. T1y is actually T1 sine 40 degrees. There we go. And I can do the same thing with my cosine, and you'll see that T1x, once you do half of this, the other half unfolds before you. T1x is going to be T1 cosine 40 degrees. Just do cosine 40 degrees and you'll see why. Let's take T2 now and do the same game. We'll break T2 into, so here's my T2. We'll break up T2 into, I want to use another color. Sorry about that. We'll break T2 into T2 in the x direction, and this would be part of the T2 that's in the y direction. So this is telling me how much of T2 is going along each axis. T2x is that portion of T2 that goes along the x-axis in the x direction. And T2y is the part of T2 that goes along the y-axis, the y direction. And you'll call this angle is 20 degrees. So the side opposite is T2y. Well, I'll just solve it the same way again. Sine 20 degrees is equal to T2y over T2. So, therefore, T2 in the y direction is going to be equal to T2 sine 20 degrees. Okay? I'll save these for later. And T2 in the x direction, the x portion of T2, that part of T2 along the x-axis in the x direction is going to be T2 cosine 20 degrees. Okay, I'll save these for later. So I've taken my forces that are not along the x or y axis and I've broken them into components. Now I need one force diagram, a new force diagram, that includes, instead of the T2 and T1 that are in funky directions, I'm going to replace T2 with T2x, T2y. I'm going to replace T1 with T1x, T1y. This will give me what's called an axis-only force diagram, where all my forces are along my horizontal and vertical axes. So here's my axis-only force diagram. All right? I've got weight. Weight was already along my vertical axis. So I got weight down. And the T2y and T1y are going to add up to balance my weight. So I'll call this one T1y, T2y. And my T1x will be to the left. And that should exactly balance my T2x. So now I should be ready to solve for everything. So I'm going to use first law along the x-axis, and then I'm going to use first law along the y-axis. So sum of the forces in the x direction equals 0, as we stated before. I'm not going to put an arrow above this because I'm labeling my direction as along the x-axis. And this is because, or since, there is no acceleration along the x-axis. So this is telling me that T1x, well, let's do T2x first. And I'll make this way positive, I'll make up positive. So positive T2x plus negative T1x has to equal 0. In other words, T2x has to equal T1x, okay? And T1x is T1 cosine 40, and it's T1x. T2x is T2 cosine 20. I actually switched these, but that's okay. So I can't actually solve for anything yet here. So I'm going to go ahead and sum the forces in the y direction and see what I get there. Sum of the forces in the y direction equals 0, since there's no acceleration in the y direction, right? So my T1y plus T2y. So let's see what my T1y is. Okay, T1 sine 40 degrees, right? And that's up, so I'm going to make it positive, plus T2 sine 20 degrees, which is also in the positive direction, plus my weight, which is in the negative direction. All of these have to add to 0. Okay? Now, I know my weight, but that's it. So now I'm going to see here. Why don't I take T1 sine 40 degrees plus T2 sine 20 degrees has to equal my weight. Did I calculate my weight already? Well, my mass is 50 kilograms. So if my mass is 50 kilograms, my weight is going to be 50 kilograms times 10 newtons per kilogram. That means my weight is 500 newtons. Okay? So this expression has to equal 500 newtons. Okay? Now, there's a lot of ways you could do this. I'm just going to solve for T2. I'll get T2 equals T1 cosine 40 over cosine 20. And I'm going to plug this in for T2. So I'll put this right here. So now I'm going to get T1 sine 40 plus T1 cosine 40 cosine 20 . All right? Okay, so I plug that all in. Sine 20 degrees equals 500 newtons. Now, at this point, it would probably be helpful to know some of those trig identities you once knew. So T1 sine, let's make this a little neater. T1 sine 40 plus T1 cosine 40. I think sine 20 over cosine 20, I think this is just going to be tangent 20. Sine 20 degrees over cosine 20 degrees. This has to equal 500 newtons. Is 0.91. Okay? So it's going to be T1 times actually it's 0.92. Okay? Has to equal 500 newtons. So T1 equals 500 newtons over 0.92. And there we go. We get about 544 newtons. That sounds right. That's what we were getting before. And now if I go over here, I can find T2. So I got 544 times cosine 40 over cosine 20. So T2 is going to be like, let's see here, cosine 40 divided by cosine 20 times 544 is about 443, which again looks about what we were getting before. So I got 443 and 544 newtons. So in my original force diagram, I've now found my T2 and my T1. So what was it? 544, 543. See which one's bigger. I already forgot. T2 is 443. T2 is 443. So this one here is 443 newtons this way. Weight down is 500 newtons this way. And then T1 I think was 544 newtons. And the problem's finally solved. Thanks for watching, and I hope you have a good day.